Hey everyone, welcome to the last section of Unit 1B. Today we're just combining a bunch of things that we've been learning throughout this chapter. So we've learned about systems of inequalities last, and now we're going to look at word problems and combine them together. So the directions say write a system of linear inequalities to represent each system, and then we're going to graph it. So to raise money to attend a Boy Scout camp, Alec is selling popcorn. Small bags of popcorn sell for $4 each. So I'm going to underline that. Large bags sell for $6 each. He needs to earn at least $300 to attend camp. He will also earn a badge if he sells at least 60 bags of any combination. So it says so what we're going to now do is write a system of inequalities for that. And since we have two different types of bags, we're going to have two different variables. So always define your variables first. So I'm going to have x equals and y equals. I'm going to say x is the number of small bags. It really doesn't matter whether you use x as small bags or y as small bags, but make sure you define them. So I'm using x as the number of small bags, and that would mean y is the number of large bags. Those are my two unknowns. And then we're going to write an equation or inequality for each of these. So the first one's going to deal with the money. So he wants to earn at least $300, and it's $4 for small, $6 times the large. So it's going to be 4x, 4 times the number of small bags, added $6 times the number of large bags, which is y. And we know he needs at least 300, so putting a 300 there. Now, at least means it could be 300 or more. So therefore, I want greater than or equal to 300. The other inequality then is going to be he will earn a badge for at least 60 bags. So when I add my number of small bags, which is x, added to the number of large bags, which is y, it needs to be at least. Again, at least means it can be 60 or more, so greater than or equal to 60. So now that we have our two inequalities, we do need to get y by itself for both of these. So remember, you're doing PEMDAS backwards, so you undo the addition subtraction. So I'm subtracting 4x here. So I have 6y is greater than or equal to, these are not like terms, so I have negative 4x plus 300. And then when I divide by 6, remember I'm dividing everything by 6, I end up with the inequality y is greater than or equal to negative 4 over 6 would reduce. 2 goes into both 4 and 6, so it would be negative 2 over 3x. And 300 divided by 6 is 50 plus 50. That is one inequality that I'm going to graph now. For the second inequality, that's a little bit easier because I'm going to just subtract x, and I'm left with y is greater than or equal to negative x plus 60. Again, those are not like terms, so therefore I just leave them as two separate terms. As we go now to graph this, you want to scale your axes and label your axes. So again, my x-axis is going to be small bags, or number of small bags. I'm going to write number of small bags. My y-axis is number of large bags. And since I have to get up to 60, I can't go by ones. I don't have 60. Again, the reason I know I have to get up to 60 and 50 is because those are my y-intercepts. So I'm going to go by 5s. Okay. And I'm going to label every other. So 5 10. Again, make sure that's 2 blocks for 10 because every block's 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. And then I'm going to do the same. I'm going to keep the scale the same on my x-axis as well. That way I can just count my blocks for slope. So again, 5, 10. So 5 is the first block. I'm not labeling that. You can if you want. 10 is the second. 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. All right, now that I have that, I can graph each of my inequalities. Now I'm going to use a pencil and a pen for now. All right, so the first one I'm going to do is this negative 2/3 x plus 50. I'll use that pencil for that one. So I'm starting at 50. I'm going down 2 and over 3 to the right. And since, again, I kept my scale the same, even though the scales aren't going by 1s, they're both going by 5. So I can just count blocks. I'm going down 2, 1, 2, over 1, 2, 3. Down 2, over 1, 2, 3. Down 2, 1, 2, 3. Down 2, 1, 2, 3. And I suggest you go as far as you can through the whole graph. And again, the one key here that I just repeated was, as long as I keep my scale the same, in this case each block represents 5, I can just count blocks for my slope, down 2 over 3. So I highly recommend when you're doing these problems to keep your scale the same on each axis. So when I do this, I have an equal to, so remember that makes a solid line. And then it's a greater than symbol. So my greater y values would be out here. So I'm going to just, again, a couple quick out there. As I go now to my second inequality, I'm going to do this in a black pen. I'm going to start at 60. And go down 1 over 1. Because again, my slope's negative 1. So it's negative 1 over 1. Down 1 over 1. Again, I'm going to have a solid line because it is equal to. And then again, it would be greater than. So I'm shading outwards again as well. So what that means is that my double shading, or my answer, is going to be above both lines. So it's going to go, make it nice and dark here. This is kind of the outline. It's above that black line. And then right here, it's also above this. So it's not in that little region there, not in this little part of the X, not in that part of the X. Those are not the double shaded region. The double shading part is all out there. So now it says, using your graph, give 2 possible combinations of bags of popcorn that Alec can sell to attend camp and earn his badge. So, remember, anything in the double shaded region would satisfy both these inequalities, which means he's earning at least $300 and selling at least 60 bags of popcorn, which is making him attend camp and earn his badge. So you can pick anything in the double shaded region. Or on the solid line. So, for example, I could put the 0.555 because that is on the double, in the double shaded part of the solid line. I could not put this though of 547 because that's not in the double shaded part. I could do up here or here or here. I could also do this point 6010. So I'll do 60-10, which would be on the solid line near the double shaded, or again, anything in that shaded region. So I'll do 30-70. If you have a question like this, I'd always be safe and just go in the double shaded region. All right, one more. Greg needs at least $1.60 in stamps to mail a package. He has 28-cent stamps, 28-cent and 4-cent stamps. He can use no more than 24-cent stamps as he only has one book left. So now this inequality, we have two different types of stamps as our inequalities. So X is the number of 28-cent stamps. And then Y is the number of 4-cent stamps. With that being said, we go ahead and write an inequality. So when we add our 28-cent stamps plus our 4-cent stamps together, we had to have $1.60 worth of money. So we're taking 0.28, that's 28 cents, times the number of 28-cent stamps, which is X, plus 0.04. So be careful on that one. Remember, 4 cents is 0.04 times the number of 4-cent stamps. And that is, it has to be at least $1.60. So again, that would be greater than or equal to 1.60. Now, if you wanted to do everything in terms of cents, you could. You would have 28, 4, and then 160. I think it's better to just keep it in terms of dollars, though. All right, and then the other thing it says is that he can use no more than 24-cent stamps. So that means the number of 4-cent stamps, which is Y, and no more than will be less than or equal to 20. So this second inequality only had one variable, a Y. And I'm going to rewrite that here. And I'm going to solve for Y. So we got one inequality where Y is already by itself. If we look at this second one, getting Y by itself, I'm going to subtract 0.28x. So I have 0.04y is greater than or equal to negative 0.28x plus 1.60. We're going to divide each side by 0.04. So our final inequality will be y is greater than or equal to, and when I do negative 0.28 divided by 0.04, I get negative 7x. Again, use your calculator, but you'll get negative 7, and then put the x on it. And then 1.60 divided by 0.04 is plus 40. So those are the two inequalities. So as I go to make my graph, so we have number, x-axis, number of 28-cent stamps. And y is going to be number of 4-cent stamps. Again, we've got to consider our scale. And you want to try and use as much of the graph as possible. So like don't go by tens, because if you go by tens, you're only going to be using like this tiny part of the graph. And even fives might be a little low for this one. It's up to you. Fives would probably work. I'm going to actually go by twos though, because twos would be enough. We have 20 blocks here, and we only need to get up to 40. So I'm going to go by twos. So 2, 4. Okay, I'm going by twos, but labeling every other just to save space. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, and 40. So again, there's 20 blocks. I knew I had to get up to at least 40 because 40 was my y-intercept. So I thought 2's would be a good number to work with. And again, I do want to try and keep my scales the same. That way I can just count blocks for slope. So I'm doing the same. Going by each block is 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, and 40. Now that I have that scaled, I'm going to go ahead and do my pencil for this one. So I'm starting at 40, and I'm going, slope is -7, so I'm going down 7. And again, I can just count blocks. 1, 2, 3, 4, 5, 6, 7, over 1. 1, 2, 3, 4, 5, 6, 7, over 1. 1, 2, 1, 2, 3, 4, 5, 6, 7, over 1. I'm connecting it with a solid line because it has the equal to. And it is a greater than symbol. So again, I'm lightly just putting a few strokes that way. As I go here with the y is less than or equal to 20, I'm going to start at 20. And this is a little tricky because there is no slope there. There's no x. So that means your slope is 0. And your y-intercept is 20, or 0, 20. So you're starting at y-intercept of 20. And then, remember, 0 slope is just straight across. So this is just saying all the y values are 20. All the y values are 20. So it's just a horizontal line. Okay, everywhere on that horizontal line, the y is 20. And then it's in less than, so that would be below the line here. So therefore, our double shading, I'm going to erase up here because that's not going to be in our double shading. Our double shading is above this solid line and below this horizontal line, so we're down here. And again, we can use the graph to state any two combinations. So it can, again, it's any ordered pair in the solid region or in the solid line here, or solid line there. So I'm going to do, say, 1220 would be on this solid line, which is okay. And I can use anything right here as well. That's a 16. Anything in there. So 12, 8. Okay. All right, that's systems of inequalities. Word problems. Everyone's favorite.